highlight this, absolute value function, has the form y equals the absolute value of some graph or some function inside. So what we're going to do we're going to sketch the inside first in our example. That would be y equals 3x plus 6. So if I sketch the inside first, which I'll do in black because I wrote it in black, would you agree that you have a y-intercept at 0, 6? And the slope is 3, which is positive, meaning your line has to go up. So if I use a slope of 3, I could go down 3 over 1, down 3 over 1. That would give me an x-intercept at -2, 0. And here is the line y equals 3x plus 6. So second thing we're going to do, since the absolute value makes all the y values positive, because if we look at the equation, y equals absolute value of something. And the absolute value makes something positive, so you know that all your y values have to be positive. So what we're going to do is graph y equals the absolute value of f of x by just flipping the negative y values over the x-axis. The positive y values, what happens when you do an absolute value of a positive number? It stays the same. So the positive values, and this is where my y values are positive, so it makes sense those would stay the same. Because if you did the absolute value of 6, you would get 6. But if I did the absolute value, and I can take a point here, for example, when I plug in -3 into this equation, I'm going to get -3, -3. But in this equation, when I plug in -3, I would get the absolute value of -3, which would make it +3. So on the blue graph, I will label -3, +3. And I take this whole section and flip it over. It's like taking the bottom part up and reflecting it and flipping it over the x-axis to get my new graph. Would that be called perpendicular? Well, it's flipping straight up and down. So I mean, if I join these 2 points, it would be perpendicular to the x-axis, but you're just flipping over the x-axis. So notice that on the original graph here, I have a y value that was negative. On my absolute value graph, that value is positive. You could do a table of values like they did in the examples that we did before and see that. But the quicker method is saying whatever my y values were negative with my original function, the absolute value is going to make them positive, which is going to flip them up and over. Now, for the blue graph, it says identify the intercepts. Well, oops, that's not blue. My y-intercept is 0, 6. My x-intercept was -2, 0. The x-intercept is going to be a very important point, because that's where you're going to get the sharp, pointy part of your graph when you flip it over. 0 is the smallest you can get before the absolute value changes something. Okay, we want the domain of our blue graph. The domain is still everything, but the range, the y values are now bigger than or equal to 0. So you can circle for 5a, 6, 7a, and 10a and b. If you'd like to circle 5, 7, and 10 completely, I'll assign the rest of them after example 2. But I'll give you some time to try those.